All right, section 3.4, we're taking a look at a couple more formula sets, product to sum and sum to product formulas. And what these allow us to do is they allow us to take, again, angles that we don't know from the unit circle and be able to manipulate with them in a way that turns it into something we can work with. I mean, that's the general idea. And there's two sets of formulas that we're seeing here. These are the product to sum identities. If you've printed these out, that's great. If you haven't printed them out, they're on that sheet that I gave you back at the beginning of section 3.1. And then we have some here that are the sum to product identities. Okay. You might notice that if you look at this in your textbook, there is this one right here. I think it's the last one. Yeah, this one right here. It shows up in two different forms in your book. And I've only got one form written here. And the reason I only have one form written here is because you don't need two forms. And here's what I mean, is that if you have sine of alpha and cosine of beta, if we were to change the order around and write cosine of beta, sine of alpha, we can do that because sine and cosine are both present, and I'm just switching the order. That's a commutative property. So there's not really a different formula. They're presented in two different formulas in your book, but there's no need for that. So I've chosen to just list them as one. Okay, so that is a variation that I've making from your textbook that I wanted to draw your attention to. Okay, so we have these three, and then we have these four identities, and we're going to take a look at finding different quantities, consolidated or more expanded, depending on the perspective of the question. So this one asks us to express the product, because it is a product, right? It's multiplication. We have two signs that are being multiplied, as a sum or difference. So we're going to take a look at this. It has two different signs that are multiplied, and we want to find one that has two signs that are multiplied, and it's this one right here that matches that form, right? Two different signs that are multiplied. And we're going to apply this formula. So this says that I'm going to put a 1/2 at the front, and then I'm going to have the cosine of the angle subtracted. And I'm going to subtract the cosine of the angles added. Okay, so this is the formula I'm going to be employing on this particular problem. So I'm going to write the 1/2 in front. And then it's a cosine. And it first said the angles subtracted. So this is theta minus 2 theta. And then I'm subtracting. And then this is a cosine of the angles added. So theta plus 2 theta. Okay, so we see where all the pieces came from and why they went there. We're not going to stop there. If we have the ability to simplify things, which we typically will, we will simplify. So what is theta minus 2 theta, this piece? That is negative theta. And then what is theta plus 2 theta? 3 theta. Okay, yeah, we can't combine the cosines, right? But what we can do is we can write cosine of negative theta in a different way. And if you look back again at the earlier formulas that we've done, this is an even-odd identity. Do you remember it? What is it?
Is it just negative cosine of theta?
Close. That's what we do with sines and tangents. Cosine's negative angle identity is that the cosine of negative theta is exactly the same as the cosine of theta. It's an even function. So if we look at that one, it will change actually just into the cosine of theta. Okay, so this is an even-odd identity. Specifically, it's an even function, so we actually have the ability to have the negative inside removed, and it's the same quantity. And the last thing we're going to do is just distribute our 1/2 through, which you could have done at any point along the way if you'd liked. So this is 1/2 cosine theta minus 1/2 cosine of 3 theta. Now, that doesn't really generate a lot of why in the world did we do that? Because, I expressed it in a different way, but these angles are just arbitrary angles, right? So I think that our next example has values. Nope, it doesn't. I think it's a different lesson. 3 has some values. Okay, so when we get to number 3, a couple problems in, you'll actually see the ability why we're doing these formulas, or why we would want potentially to do these formulas. So one more before we get to that. All right, this one asks us to do the opposite. It starts out as angles that are subtracted, or not angles, excuse me, trig values that are subtracted, and it wants to consolidate them back into a product. Okay? So we're looking for a formula that has a cosine minus a cosine. That's what we're looking for. So over here is where we have cosines that are subtracted down here at the bottom. So I have a cosine minus a cosine. Okay, so all of this is like, it's like a matching game, right? Like memory, like if you ever played the memory matching games, like as a child, you're just trying to match them up. You're figuring out which one do they look like, and then you're going to do what's on the other side. It looks like the left-hand side of this. And so we're going to take what's on the left-hand side and manipulate it to what looks like it's on the right-hand side. So I'm going to end up having a negative 2 sign here. That's going to be where it's going to start. So this will start with negative 2, and it'll say sine. And then I need to have the two angles added divided by 2. So whatever's in here need to be added together and divided by 2. Well, I'm going to write it out very clearly. This is 5 theta and 3 theta divided by 2. We will clean that up before we're done, right? So that's the first half-ish. And then it says I'm going to have another sign, right? But now I'm going to subtract first one minus the second one and divide by 2. Okay, so another sign. And now I have the first one, 5 theta, minus the second one, 3 theta, divided by 2. Is everybody okay? This is the matching part that we just did. We just took the pieces on the left and we matched them up, and then we did what it told us to do on the right. Now we're going to clean things up. So the negative 2 sign at the front stays there. What happens when I have 5 theta plus 3 theta? 8 theta divided by 2 would be 4 theta. And then the second piece, 5 theta minus 3 theta, 2 theta, divided by 2, theta. Okay? So this is the different expression in a product form than when we started with it in a sum or difference form, in this case a difference. Okay? Our next example is the one that tells us why we're doing it. Okay? So here's one that we don't have unit circle values that we've memorized for 75 degrees or 15 degrees, right? I mean, I haven't. Have you? Anybody memorized those for those? No, those weren't on our unit circle, right? But if we use these formulas, we're going to change it into something we can use that we've memorized. We're going to manipulate it in a way that's helpful. This says plus. This one's plus. Sine plus sine, right? Those are the two things. We're adding two signs together. So over here, sine plus sine is the one at the top. It's this one, right? Okay, so it's telling us we're going to manipulate it the way that it says on the right. We've matched it up. We're going to manipulate it. It's going to say a 2 and then a sine. So this will change to 2 and then sine. It says I'm supposed to add the two angles together and divide by 2. Okay, so I have 75 as one angle and 15 degrees as my second angle, and I'm going to divide by 2. We will come back and do that, but right now we're just filling in the blanks, okay? Then it says I'm going to have the cosine of the angle subtracted and divided by 2. So I have the cosine, the angle subtracted is 75 degrees minus 15 degrees divided by 2. Okay, just writing this out is partial credit. Okay, so this is just a plugging in, making sure you can identify and put things in the places, okay? You guys have been doing that for years with algebra. Okay, this isn't a new skill. You can do that. After that, we're going to do the trig part, okay? So this is the matching part. Now we're doing trig. All right, so what's 75 plus 15? 90, and 90 divided by 2 is 45, and that's kind of a friendly angle. It's at least an angle that we're familiar with working. Familiar with working with. That's what I want to say. Cosine. All right, have 75 minus 15. 60. 60 divided by 2? 30. Another familiar angle, right? That's the reason we'd want to use this formula, is because they become angles that we know something about already. A lot of math, if you haven't caught on by now, which I'm sure you have, is pushing you back to prior knowledge, right? It's taking something new and saying, okay, we can do a little bit of stuff, and then we can go back and say we learned something before that looked like this, and we can use that. That's really what math is. It's a building on experience. This is one of those places, and specifically within this class. At this point now, we're able to use information that we've done in this class and fill in the blanks for these two values. So what is the sine of 45 degrees? Do you remember? Excellent. Square root 2. Hang on, that didn't write very well. Let's try again. Square root 2 over 2. How about the cosine of 30 degrees? Yeah, that's square root 3 over 2. So remember doing that unit circle quiz? I know it's been like a month and a half or something at this point now. It's back to that stuff. And we're going to simplify. So this 2 and this 2 will cancel, right? We actually have the square root of 2 times the square root of 3. And there is a property with square roots. This is an algebra thing now. That says when I have square root of 2 and square root of 3, since they're both underneath the square roots, I can multiply them together underneath the square root. So this is the square root of 6. Can't do it with addition and subtraction, but I can do it with multiplication. And then the denominator still has a 2 in it from over here. So this is square root of 6 over 2. And I want you to grab your calculator, and we're going to confirm that we did it right. Because we can check this. There's no reason we can't check that the answer we got is actually correct, which is helpful. Because if you made a mistake, when we get to this and we check it, we made a mistake, we know we need to go back and figure out where the mistake is, right? Okay, so you can put in the original expression that we were given, this one right here. Make sure you're in radian or in degree mode, because we're working degrees right here, right? Make sure you're in degree mode. Type in sine 75 degrees plus sine 15 degrees. Press enter, it's going to give you an ugly irrational number. You're going to get funny decimal expressions. That's fine, okay? And then you can put in what we got as our answer, square root of 6 and over 2. Make sure that when you put this in, a lot of times your calculator, depending on the version, might actually put like this. Make sure you close your 6 and before you divide by 2. It will not understand what you're doing if you put the 2 underneath there too. So do they match? Did anybody check it? Carson checked his matches, Braden's matches. Okay, cool. So we confirmed this works. Now, it doesn't actually allow us, like your calculator is a great check step here, but you can't use your calculator to do this problem. You get that, right? I mean, there's no way to start here and get your calculator to turn it into this. I know you've got like fraction buttons in your calculator, but you don't have ways to turn things back into square roots. So all you can really use it for is to check. You can't use it to do this problem, but it is a good check step at the end. Okay, everybody good? Okay, there's a couple more things in this section we're going to take a look at. We're going to take a look at verifying identities. I think I just had 2 of them, yeah. And this is just going to be like what we've been doing in every section. We're going to be trying to work with one side or the other, manipulate it, and turn it into the missing side. Okay? Manipulate one side or the other and turn it into the missing side. Now, manipulating the right-hand side here is not very helpful. And the reason it's not is because I don't have a triple angle formula. I have double angle formulas. So if this said tangent 2 theta on the right-hand side, I might actually want to start there. Maybe. But I don't have a triple angle formula. So starting on the right-hand side here isn't even going to make sense. We probably would be inclined to start on the left-hand side anyway because it looks messy and more complicated and we'd like to clean it up. So we are going to start on the left-hand side for both of those reasons. We can't start on the right and it's the messy side anyway. So this one says that I've got the sine, hang on, here we go, the sines added together. And we have a formula that allows us to take sines that are separate, right, and adding them together. It's one I just used, in fact. I used it here. So coming back over here, it's this first one. It says that if I have 2 sines, they could be the same angle, but different angles are fine too. I'm going to take the 2, I'm going to write the 2 down, I'm going to write the sine, I'm going to add my angles together and divide by 2. That's where I'm going to start. So I'm going to write down 2 and sine. I'm going to add my angles together, 4 theta plus 2 theta, and I'm going to divide by 2. Now that's part of it. I'm not finished with that top yet. That's the first part. The other half is that I'm going to do cosine of the 2 angles subtracted and divided by 2. So I want cosine of the 2 angles subtracted, so 4 theta minus 2 theta, divide by 2. That's the entire numerator. Looks messy. We'll get it more cleaned up in a second. Now the denominator has the cosine values that are added together, right? So we're going to go back to that same slide here. Look for 2 cosine angles that are, was it added? Yes. Yeah, added. Okay, cool. So it's this one now. We haven't used this one yet. It says I'm going to do 2 cosine of the angles added and then cosine of the angles subtracted. Okay? So we'll do cosine of the angles added. So 2 cosine angles added, which would be 4 theta plus 2 theta over 2. And then the cosine of the angle subtracted, 4 theta minus 2 theta over 2. I'm going to choose to clean this up a little bit before I start marking things out too bad. I think we're probably all okay with the fact that these 2's cancel, right? So I'm going to mark those out right here. But I'm going to clean up all 4 of the other individual chunks before I start canceling anything else, okay? So on the top, I have the sine. What's 4 theta plus 2 theta? 6 theta divided by 2? 3 theta. Okay, then I have cosine. What's 4 theta minus 2 theta? 2 theta divided by 2? Theta. All right, denominator, cosine. And I actually have the same angles added and subtracted that I just did. I have 4 theta plus 2 theta is 6 theta divided by 2 is 3 theta. And then 4 theta minus 2 theta is 2 theta divided by 2 is theta. Do you see something else that cancels? Yeah, the cosines. And the reality is that we could have, if we'd recognized it here, seen that they were the same at this point too and canceled them. Do you see that they're exactly the same? You could have canceled them there. I chose to simplify them because I thought it was easier to see that they really are the same in the next step. And I'm going to do the next step anyway for the other part. So either way, you can do that. So this leaves, let me show you clearly where we're at. This is sine of 3 theta over the cosine of 3 theta. This is an identity you've memorized. Some of you have got it down. Your gateway's done. Others of you are still working on keeping those and getting those all memorized. But this is a quotient identity. Sine divided by cosine is what?
Cotangent.
Nope, it's tangent. Yeah, sine over cosine is tangent. This is the tangent of 3 theta. And that's good news. Why? Because that's what we wanted on the other side anyway. Yep. So at this point, we're there. It's equal.
So are we going to get these on the test too? Or just
Yes, you're going to get a sheet that's everything except for those top 3. You're going to get a sheet. In fact, I've printed it out. You'll get it on the quiz on Monday, and you'll get it on the test next Wednesday. You'll get both of them. So it'll have all these identities, every single one of them. It's up to you to be able to use them properly, but you'll get all the identities for your test and for your quiz on Monday, okay? Just not those first 3 that you've memorized for your gateway, which is the Pythagorean identities, the reciprocal identities, and the quotient identities. Those 3 you have to have memorized, okay? All right, we have one more identity to do. Hang on, there we go. Apparently I have 2 slides in there for the same thing, that's all right. So we have sine of alpha plus sine of beta over sine of alpha minus sine of beta. And this is equal to the tangent of alpha plus beta over 2 times the cotangent of alpha minus beta over 2. And both sides look plenty messy, correct? They do. So when we're in a position like this, we probably want to look at it and try and figure out which one of any of these pieces I actually have formulas that allow me to manipulate. Which side, left or right, does it look like I have formulas that will allow me to manipulate this? The left-hand side, right? Signs that are added, signs that are subtracted. That's one of the sets of formulas that I've been working with. So that's the one that I'm going to be manipulating is my left-hand side. Now you might be looking at the right-hand side and saying, okay, but aren't tangent and cotangent reciprocals? And yes, they are. But do you notice that these 2 angles are different? They're slightly different, right? There's a sign that's going to be messing things up, but they are not the same angle. And since they're not the same angle, I can't just mark them out and say that they're equal to 1, right? So if I had tangent of theta times cotangent of theta, they would equal 1. It's one of the kinds of things you've been seeing happening on your gateway. But that has to have the same angle, and they're not the same angle on the right. So the left-hand side, I definitely have formulas for in this section that I can work with. I'm going to start with the left-hand side. All right, the top part, sine of alpha plus sine of beta. Okay, so we've done this over here. That's the top one. So it's 2 sine of the angles added divided by 2 and cosine of the angles subtracted divided by 2. So I have 2 sine of the angles added, so alpha plus beta divided by 2, and then cosine of the angles subtracted, alpha minus beta divided by 2. Denominator. We've got sines, angles subtracted. It's the one that we haven't used, right here in the middle. So this is the one I'm on right now. This one has 2 cosine of the angles added, sine of the angles subtracted. So 2 cosine of the angles added, sine of the angles subtracted. Okay, what reduces on the left? The 2's. Yeah, the 2's reduce. And none of the rest of them reduce. Right? So like I see a sine here. Yeah, like there's a sine here and there's a sine here, but their angles don't match. Correct? And the same for the cosines. The angles don't match. So I can't just mark something out like I did on this problem. I don't have the ability to do that on this one, right? Okay, so what am I going to do then? Whoops, sorry. So what we're going to take a look at then is what pieces have angles that match. So if you notice right here, the angles match here, right? Now, I can't mark the angles out. That's not what I mean. But I do need to notice that the angles match. And if the angles match, it puts me in the same position that happened down here. My 3 thetas matched, right? And because my 3 thetas matched, I could consider the fact that I had sine over cosine and turn it into tangent. Yeah? The same thing's happening here now. These angles match. And again, I have sine over cosine. And what is sine over cosine? It's tangent. It's tangent of this still really funny looking angle, but to be honest, that's not all bad because that's the angle I'm looking for on the right anyway, isn't it? It is. And not only that, but if you take a look at the next one, the angles match as well. You have alpha minus beta over 2 in both of those. So then, what is cosine over sine? That one's the cotangent one. And again, good news, that's exactly what we wanted it to be to match what was on the right.
You still work the right, like if you chose to.
We don't have a formula to separate that out and to work it on the right. Like we don't have a tangent of alpha plus beta over 2 formula that allows that to separate out. Yeah, so since we don't have a formula, we're sort of stuck again with working on the left. That's the only place we can work. Okay, everybody good? All right.